Let x be a sequence of 10 coin flips. Let y be the number of consecutive heads at the beginning of x, and let z be the number of heads in x. We need to write down the probability function of y and of z. Solution. Consider z. Z can take values in 0, 1, up to 10. So we need to write down a function pz that maps from this set to the interval 0, 1, where pz at k is the probability that z equals k. We can compute probability z equals k directly by looking at which values of x would give the event z equals k. There are 2 to the 10 possible toss sequences of heads and tails. There are 10 choose k possible toss sequences with exactly k heads. So the probability that z equals k is 10 choose k divided by 2 to the 10. We can also use the binomial distribution. Since the tosses are independent and have the same success probability a half, z follows the binomial distribution with n trials and success probability 1/2. So therefore, probability z equals k is 10 choose k, a half to the k, 1 minus a half to the power of 10 minus k, which simplifies to the same expression. Now let's consider y. Y can also take values in 0, 1, up to 10. Again, we can compute probability of y equal k directly. Y equals 0 means there are no heads before the first tail. So probability y equals 0 is exactly the probability that my toss sequence starts with a tail. And this probability is a half. Y equals 1 means exactly one head before the first tail. So probability y equals 1 is the probability that the sequence starts with head, tail, and this happened with probability a half times a half, which was 1/4. So in general, py at 0 is a half, and then for k from 1 up to 9, probability y equals k is the probability that the sequence starts with exactly k heads before the first tail. So this happens with probability a half to the k, because we need k heads, and then times a half, because the next toss, the k plus first toss, has to be a tail. And finally, probability y equals 10 is the probability that the sequence consists of 10 heads and no tails. So this happens probability a half to the power of 10. To double check our work, we can check that the sum of these probabilities is 1.